Okay, so now we're gonna start comparing the two means with confidence interval and test of hypotheses. So let's take a look. Independent random samples from a normal populations produce the results shown in the table to the right. So I see there was a sample one. There's 5 samples in sample one, and there's 4 cases in sample two. Assume that the population variances are equal. Okay, so what do we mean with variances? So whatever we're testing, if it is medicine, so let's say everybody involved in the studies, they had the same exposure to the same disease that we're studying. Like if it's with temperature, they were all with the same temperature. That's what it means with assume that the population variances are equal. Now there is something that we call variance. Remember, standard deviation is the square root of a variance. It's a different variance from what it's mentioned here. So now it says calculate the pool estimated of the variance. Okay. So there is a formula. There's a formula we're going to be using. So the sample, I'm going to use S for sample. Sample squared, because remember it is the standard deviation squared, that's the variance of our population. Okay. This is a formula we're going to be using. So it's going to be a fraction. Going to be a nice fraction. To begin with, I'm going to go N1. So how many samples are there? How many numbers are there in sample one? Minus 1. And I'm going to multiply this by the variance of sample 1. Plus, I'm going to go N2 minus 1. Remember, N2 is how many numbers we have in sample 2. And I'm going to multiply this by the variance of sample 2. And at the bottom, I'm going to divide all of this by my degrees of freedom. Okay, so how we're going to find out our degrees of freedom? I'm going to add, I remember how on the table yesterday, I had you guys numbered, I subtracted 1. But the thing is that I have to subtract the 1 from my sample 1, and I have to subtract the 1 from sample 2. So what I'm going to do N1 plus N2. So how many numbers do I have? How much data do I have in sample 1? How much data do I have in sample 2? Minus 2. Because remember, I have to subtract 1 from sample 1 and subtract 1 from sample 2. So I might as well subtract 2 altogether. So I think my N1s, my N2s, I have them. I know how many numbers are in each sample. The only thing is that I don't have the variance of my sample 1, and I don't have the variance of my sample 2. So this one is actually what's going to require a little bit of work. So this is what I'm going to do. Let me list my numbers from sample 1. And there's a reason why I gave you guys the list are small samples. So looking at sample 1, my numbers are 1.2, 2.9, 1.7, 2.9, and 2.9. This list, let me just call it X. Okay. Let me find out what's the average of this. We should know how to calculate an average. I'm just going to add all my numbers. So 1.2 plus 2.9 minus 1.7 plus 2.9 plus 2.9. Press enter. So it gives me 8.2. Divide this by 5 because there's 5 of them. So here, let me just, at the side, let me just say the average of 1 is 1.64. Okay. What am I going to do next? I remember I showed you guys how to get the variance in semester 1, like quarter 1. We talk about variance. You had to do them by hand, but just in case, some of you guys join us later. So this is a refresher for some of you, or it is something new for some others. So I'm gonna do a table here. I'm gonna go each of my numbers on the X, and I'm gonna subtract it by the average. So for the first thing, I'm gonna go 1.2 minus 1.64. Okay, wait a minute. 1.64 doesn't seem right. Okay, let me do this again. Okay, so I added all my numbers, right? 1.2 plus 2.9 plus 1.7 plus 2.9 plus 2.9. I get 11.6. Okay, so I guess I had typed it wrong earlier. 11.6 divided by 5 to get my average, I'm gonna say is 2.32. Okay. Okay, now in the next table, remember, I'm gonna go each of my x's minus the average. So 1.2 minus 2.32 gives me a negative 1.12. 2.9 minus 2.32 gives me positive 0.58. 1.7 minus the average gives me a negative 0.62. 2.9 minus the average gives me positive 0.58. And again, 2.9 minus the average, I get 0.58. Good. I'm going to make a table, another table here. I'm going to go x minus x bar all square. So I'm going to squared each of my numbers. Okay, each of my numbers. So negative 1.12 times a negative 1.12, I get 1.2544. 0.58 times 0.58, I get 0.3364. And then here, negative 0.62 times negative 0.62, I get positive 0.3844. And then here I'm gonna get 0.3364 and 0.3364. Let me add them all up. Okay, so now this is 2.648. Does that seem right? Let me double check. Okay, so 2.648. Now because it is a sample variance, I'm gonna say the variance of a sample is gonna be, in this case, 2.648 because I added all my numbers there, divided by 4. Okay, where did that 4 come from? See how many numbers do we have in our sample? 5. Okay, we have 5. Subtract 1 of it. That's how I got the 4. So when I do sample 2, I'm gonna divide it by 3. You always divide it by 1 less. Okay, so I'm gonna get 2.648 divided by 4. I get 0.662. Okay, that is my variance of sample 1. Okay, let me get my variance of sample 2. To not get confused here, I'm going to look at sample 2. So I'm going to do my list of x, all my numbers in sample 2. 4.4, 2.6, 3.8, and 3.9. I'm going to subtract each of my x. I'm going to subtract the average. Okay, so let me find out what's the average. I'm going to add all my numbers. So I'm going to go 4.4 plus 2.6 plus 3.8 plus 3.9. I get 14.7. Let me divide it by 4. So I'm going to get my average of sample 2 is 3.675. Okay. So I have to go 4.4 minus 3.675. And I get 0.725. Now 2.6 minus the average is a negative 1.075. 3.8 minus the average is 0.1. 125. 3.9 minus the average is 0.225. Now, if you guys know how to do Excel, you guys have a calculator that gives you guys the sample variance, use it. So I'm doing it by hand just to show you how it gets done. Okay, now my last table here, I'm gonna do X minus the X average squared. So 0.725 squared gives me 0.525625. Negative 1.075 all squared gives me 1.155625. 0.125 squared gives me 0.015625. Funny. They end the same. So 0.225 times 0.225, I get 0.050625. Let me add them all, and that gives me 1.7475. Okay. Now my variance, I'm going to do S to the second. So that's variance of sample 2 is going to be 1.7475 divided by 3. Okay, again, where does that 3 come from? There were 4 numbers in our sample. 4 minus 1 is 3. So I get that my variance of sample 2 is 0.5825. 5825. Okay. So now I can calculate the pooled estimate of the variance of my 2 samples. Cool. Let's do this. So I'm gonna go for, remember, I'm using the formula. There were 5 samples on our sample 1, so 5 minus 1, that's how I got the 4, times my variance of sample 1 was 0.662 plus, I know N2 minus 1 is 3. Right, there were 4 samples in sample 2, right? There were 4 numbers in sample 2. So I'm gonna call it 3 because it's 4 minus 1. The variance of sample 2 was 0.5825. And I'm gonna divide this all by my degrees of freedom. 5 plus 4 minus 2. Remember, N1 is how many numbers in sample 1. N2 is how many numbers in sample 2. So 5 plus 4 minus 2, I'm going to call this 7. Okay. Use a calculator. I'm going to round my answer to 4 decimal places. Okay, I'm going to round my answer to 4 decimal places because it gave me like 0.627929. So I'm going to round it to 4 decimal places, and I'm going to say my variance of my population here should be 0.6279. Awesome. The hard part is getting the variance of each of my samples. Again, if you guys can use Excel, you guys have a calculator to do this. Otherwise, you guys will have to do it by hand like I did. Okay, question number 2. Okay, the information is given there. So there's a sample 1, there's a sample 2. I see the average of each of my samples, and I see the standard deviation. Notice real quick here. I want you to pay attention to here. I call this variance of sample 2 because you see how it is S of 2. So that's why I know it's sample 2. But because it was to the second power, I call the variance. Notice here, it just says S of 2, but it's not to the second power. So that's why I call it standard deviation, right? If it was to the second power, I'll call it variance. Okay, cool. So now that we know that, in order to compare the means of two populations, independent random samples of 390 observations are selected from each population. Wait a minute. So that just told me my N of 1 is 390. My N of 2 is 390. Let me change this to blue so I don't get confused with the previous question. Okay, with the results found in the table to the right. Okay, so I see, again, my average and my standard deviation of each of my samples. Use a 95% confidence interval, okay? 95% confidence interval. Remember I told you, we're still using the C-score table. Using the C-score table, I know that my C-score of 95% is 1.96. Remember that, okay? So we're gonna use our C-score. So use a 95% confidence interval to estimate the difference between the population means. Mean of sample 1 minus the mean of sample 2. Round to 1 decimal place as needed. Okay, so this is what I'm going to do. This is a formula we're going to use. Let me use black to emphasize it's a formula. First, I'm gonna go there, x1 minus x2. So the mean of sample 1 minus the mean of sample 2, right? We can subtract those easily. Plus or minus, because I know for my confidence interval, gives me 2 values. So plus or minus my C-score, which we know is 1.96, times the square root. And now this one's going to be interesting. The square root of, I don't need the standard deviation, I need the variance. So I'm going to go from sample 1, the variance. So basically 158 squared divided by N1. So how many are numbers in that sample? Plus the variance of sample 2 divided by N2. All of this inside my square root. Okay, make sure you guys know how to type to your calculator. So I'm thinking the first part, well, let me highlight the hard part. That's going to be the hard part. Everything else here is not too bad, right? You guys can easily do x1 minus x2, right? The averages of x1 minus the average of x2. So let me just go 5321 minus 5286, because we can do that. So it seems like I have 35. Oh, I said I was going to do blue on this question. So I have 35 plus or minus 1.96, right? So far, it's easy. But the 1.96, it is multiplied times the square root of 158 squared divided by 390 plus 201 squared divided by 390. So I'm going to type this on my calculator. You guys are struggling on how to type this on your calculator. Depends on the calculator you have. How do you type it? Okay, you need help? Contact me. Remember, during school hours, I'm always available. So contact me. How do you type this, Mr. Leonzo? I gave you guys, in the homework, I'm giving you guys access to a scientific notation. I mean, scientific calculator. So you guys should be able to type this. Okay, for the low number, I'm gonna use minus. So I'm gonna go 35 minus 1.96 times. And then I do my square root. 158 squared divided by 390 plus 201 squared divided by 390. I press enter. My answer, let me round it to 1 decimal place. And I'm gonna get, my lower number is 9.6. Make sure you type it on a calculator. Make sure you get the same number that I did. Okay, now for the big number, let me use the plus sign. So I'm gonna go 35 plus 1.96 times the square root of 158 squared divided by 390 plus 201 squared divided by 390. I typed the whole thing on my calculator. My answer, let me round it to 1 decimal place, and I'm gonna get 60.4. So I am 95% confident that the difference of the means is in between 9.6 and 60.4. Now, next part, using the idea that we have here, I'm still going to use this. Test the null hypothesis. So the null hypothesis says that the difference of my means is 0 versus the alternate hypothesis that the difference of my means is not equal to 0. And give the significance level of the test and interpret the result using alpha to be 0.05. What is the test statistic? So here I'm going to be using the C-score, but let me go back to blue still. So I'm going to say my C-score. I'm going to using my C table, but my C-score using two populations, it's going to be, first of all, let me go the average of sample 1 minus the average of sample 2 minus the difference of O divided by the standard deviation of x1 minus x2, the averages of those. Okay, so we have information. I know what x1 crossbar is, x2 crossbar is, so I can do those. Now this thing right here, what is this d to the 0? I'm checking it with this number right here from my null hypotheses. I'm saying my difference is 0, so this number is going to be 0. Remember, this little 0 here, this means d of the null hypothesis, because I'm checking it to 0. So it's going to be easy to work. Now, this thing right here, how do I do the variance? Okay. Let me show you. I remembered, I showed you guys that I need the standard deviation, right? So I know the variance. So to the second power, I know the variance of x1 crossbar minus x2 crossbar. The variance is going to be S21 over N1 plus S2 squared over N2. That's the variance. But I need the standard deviation. So to get rid of this squared, I'm going to do the square root of this. Like, wait a minute, I just did that. You see how we just did that? Okay, so you did it in the previous question, right? The highlighted part. If you have that decimal, you can use that still, okay? So I'm just gonna type this in. I'm just gonna go X, see the difference is it's gonna be 35 minus 0. Again, my 0 comes from here. Divide this by the square root of S21 divided by N1 plus S2 squared divided by N2. Okay, you have it from the previous question. I'm just going to type it in on my question here. So I'm going to just type the whole thing here. So I'm using a calculator, so it's fine. I'm going to go 158 squared divided by 390 plus 201 squared divided by 390. Don't forget that everything at the bottom is inside the square root. Okay. Press enter on my calculator. I know for C-scores, we usually round it to 2 decimal places, and it even reminds me, round to 2 decimal places as needed. And my C-score here will be 2.70. Okay. Now, continue reading here. It says, what is the observed significance level or p-value? Okay, according to my C-score, remember how my C-score is 2.70? I use the C-table, the C-score table. According to that, it gives me my probability of 0.4965. Like I said, you guys do have the C-score table. I gave it to you guys in the past. Now, what I need to do here for my p-value, I'm going to go 0.5 minus the probability that my C-score gave me. So minus 0.4965. So my p-value, it is equal to 0.0035. Let me look at my alternate hypotheses. My alternate hypotheses had a not equal to sign. So that just made it a two-tailed probability of two-tailed p-value. So here my result, let me multiply this by 2. So I'm going to go 0.035 times 2. Again, because of my my alternate hypotheses had the not equal to. Okay, so 0.035 times 2 gives me 0.007. My answer should be in 3 decimal places, so I'm good. 0.007 sounds right. Now let me continue reading. Suppose the test was conducted with the alternate hypotheses that the difference is greater than 0. I'm just looking at this sign here. Suppose that it was with the strictly greater than 0. So that is just a single tail p-value. What is the observed significance level or p-value? Well, it is just 0.0035, not times 2. Remember on this previous one, I did multiply by 2 because I was comparing it to not equal to. When I'm comparing it to an inequality sign, I don't go times 2. But I see that my answer should be rounded to 3 decimal places. Okay, so I'm going to call this 0.004. Okay, let's take a look at another question here. Let me change this to red. Okay, 2 independent random samples have been selected. 100 observations from population 1 and 100 from population 2. So let me just say it. N1 is 100. N2 is 100. The sample means are given. Okay, so the sample mean of sample 1 is 68. the sample mean of 2 is 47. From previous experience with this population, it is known that the variances are, and they're given. So I'm going to say the variance of population 1 is 121. The variance of population 2 is 64. Now they want me to find the standard deviation of the difference of the sample means. Okay, so my formula, let me write this in black. My formula for the standard deviation or the difference of the means is, first I'm gonna go variance of sample 1 divided by N1 plus the variance of sample 2 divided by N2. And then all of this inside the square root. So I have in the square root, I'm gonna go 121 divided by 100. You guys might be like, wait, Mr. Leonzo, why are you not squaring 121? Because notice how the information that I got was already the variance. It's already from population 1, it's to the second power. So I didn't get the standard deviation. I got actually the variance of it. So good, I don't have to square it. My information just made it simple. Plus, it's still inside the square root, plus 64 divided by 100. Might be like, Mr. Dunso, why are we not using the sample means? We'll use them. We'll use them. Hold on just a second. Now I type this in. My instruction said round it to 4 decimal places as needed. My answer, let me round it to 4 decimal places. I want to call this 1.3601. Now, consider the null hypothesis that the difference is 5, and the alternate hypothesis that the difference is not 5. Construct a 95% confidence interval. Okay, I remember that 95% confidence interval, my C-scored is 1.96. I'm going to use that in a little. My answer, I'm going to run it to 2 decimal places, not my work, my answer. Okay, so my formula I'm going to use for this, I'm going to go the sample mean of 1 minus the sample mean of 2 plus or minus my C-scored. This one I know is 1.96 times the square root variance of 1 divided by n of 1 plus the variance of sample 2 divided by n2. Well, guess what? This right here, this square root, isn't that what we just solved? Okay, so that's not that bad. That's easy. What's what's the difference of the variances? Well, 68 minus 47. That's not that bad, right? So let's see, what do I have here? I have 21. My first parentheses, let me call this 21, right? 68 minus 47 plus or minus 1.96 times 1.3601. Like, wait, where did this come from? From the previous question. Isn't that what we just worked? Okay. My answer, I'm gonna round it to 2 decimal places. So let me go 21 minus 1.96 times 1.3601. My answer, let me round it to 2 decimal places. So my confidence interval will be from 18.33 to, now use the plus sign, 21 plus 1.96 times 1.3601, and it should give you 23.67. Again, pause the video. Make sure you type all the work. Make sure you know how to type it on your calculator. Make sure you get the same answers as I do. Now, our last example from today. Researchers investigated the speed with which consumers decide to purchase a product. Now, the researchers theorized that consumers with the last names that begin with letters later in the alphabet, so towards the end of the alphabet, will tend to acquire items faster than those whose last names begin with letters earlier in the alphabet, which we call the last name effect. So MBA students were offered tickets to a baseball game. Okay, so far we're saying if your last name or the first letter of your last name is it towards the end of the alphabet, according to this study, you tend to buy things quickly. Now, if the last name, the first letter of your last name is towards the beginning of the alphabet, you kind of think about it still. Okay, so then people were offered tickets to a baseball game. The first letter of the last game of respondents of the response times were noted. So people are doing this study to see if it's true. The researchers compared the response times for two groups. Group 1, those with the last names beginning with the letter A through I. So those are the beginning of the alphabet. And in sample 2, those with the last names beginning a letter R through Z. So those at the end of the alphabet. Everybody else is not counted in this sample. So I would not be counted because my last name starts with an L. Now, the summary statistics for the two groups are provided in the table below. 15 people from each group. The mean response for the first 9 letters is 20.42. The mean response in minutes for the last 9 letters is 13.20. So far, yeah, it seems like people with last names R through Z just buy quicker. The standard deviation in minutes for each, we can see it. Now we're going to construct a 90% confidence interval for the difference between the true mean responses times for the MBA students in the two groups. Assume that the population variances are equal. Okay, now how do we do this? Now the variance of my population, I know I worked something like this at the very beginning of today's lecture. I'm going to say it is going to be N1 minus 1 times the sample variance plus N2 minus 1 times the sample variance, all divided by my degrees of freedom, which is N1 plus N2 minus 2. So how am I going to do this? Let me do it here in blue. So I'm going to go 14. I'm going to say this is equal to something. Okay, what is this equal to? I'm going to go 14 times, I know my standard deviation is 7.19. So that means 7.19 squared plus 14 times 8.03 squared. And all of this divided by 15 plus 15 minus 2. I'm just going to call that 28. Okay, type it on a calculator. Type it in on your calculator. This is just my variance. I'm not quite done with this. Still going to work after this. So type this on a calculator. What I got was 58.0885. Now, let me give you guys your formula for your interval. It's going to be the difference of the means, of the sample means, plus or minus your t-value. Okay, I'm not going to use the c-score now. I'm going to use the t-value times the t-value. Remember how I showed you guys last time how to get the t-value? Okay, I'll come back to that in a minute, but I'm going to multiply this by the square root of the variance of the population. That's fine. I have this numbered, but inside of this, I'm going to multiply this by 1 over n1 plus 1 over n2. Notice how I have a parentheses inside the radical. Inside the square root, I have a parentheses. Okay, make sure you do that. Now, x1 minus x2, the difference of the averages, that's not that hard. We can see that, right? 20.42 minus 13.20. So I have 7.22 plus or minus. Okay, my t-score. I'm looking at a 90 percentage, 90%, and my degrees of freedom are 28. How did I get degrees of freedom 28? They were 15 on each. The degrees, you remember I have to go for each, I have to subtract 1. So 15 minus 1, 15 minus 1. So combined is 28. So 90%, 90%, and my degrees of freedom are 28. So use that. So look at your table. I get 1.701. Is that what you guys got? Okay, 1 point. So 90% of 28 degrees of freedom, I got 1.701. That's my t-value. That's why I had you guys do this yesterday. Times the square root of 58.0885 times. Don't forget my parenthesis inside the radical, because inside the radical I have 1 divided by 15 plus 1 divided by 15. Okay, type this in. Use the minus part. Okay. Make sure you know how to type it in. Make sure you contact me if you need help. I gave you, again on the homework, I'm giving you a scientific calculator because I want you to be able to type it in. Need help? Contact me. Okay, so if I use the minus sign, my answer, I'm going to round it to 2 decimal places. I'm going to get 2.49. If I use the plus, so 7.22 plus 1.701 times the whole square root, I want to round my answer to 2 decimal places. I get 11.95. Okay. Let me zoom out, show you everything we did today.